All right, so our work today is more or less about slope again. Interpretation of slope, interpretation of y-intercept, and things of those matters. So the first 4 questions are all very similar. So I'll probably spend some time doing number 1, and then I'll kind of like hustle through 2, 3, and 4, just to make the video short and sweet. Okay, so number 1, the function shows how the cost of a hamburger with different numbers of toppings, or shows the cost of a hamburger with different numbers of toppings. F of t equals 1.90 plus 1.40 t. What is the y-intercept? Now, right off the bat, it's not very familiar to us, but this is indeed written in slope-intercept form. F of t is essentially our y value, and this is really 1.90 plus 1.40x. Okay, or t, if you want to call it t, right? Essentially, it is slope-intercept form. If you just rearrange it a little bit, you'll see it a little better. Y equals 1.40t plus, well, this is hard to do with my computer as far away from me as it is, t plus 1.90, right? The t and the plus sign don't look good together, but it is what it is. All right, so this is a little more obvious now that we see, hey, this is our slope value, this is our y-intercept value, right? mx plus b. So that clearly shows to us that our y-intercept is 190, right? 1.90. Now, what does this mean? What is this y value representing? Remember, t is toppings, right? So the 140 has to deal with toppings. The 190 is the price you pay if you don't get any toppings, right? If t was 0, the 1.40 would disappear, right? And you just have 190. So 190 is the price of the burger without any toppings, just kind of the plain hamburger price, okay? So price of burger with no toppings, essentially. Just how it comes. What is the slope? Now, again, we've already written this equation in slope-intercept form. We can clearly see the slope is that 1.40. Now, what does this mean? Well, this is about toppings, right? It's 1.40 per topping. That's the price that we're talking about. That's the price per topping. So this essentially is claiming that toppings are $1.40, right? It's the price of each topping. So basically what we see in this equation is $1.90 is the price of the burger, and then $1.40 is the price of every additional topping. That's what we get out of this y-intercept and our slope. So if Jody paid $3.30 for a burger, how many toppings were on Jody's hamburger? So remember, we had the function f of t equals 1.90 plus 1.40t. Now, f of t represents the total price. Now, we know at the end of the day that Jody here is paid $3.30. So $3.30 as the total price, right? So $3.30 equals 190 plus 1.40t. We're trying to figure out t. What is t? So we just have to solve this equation, right? Simple algebraic equation. So we would start by subtracting 190, right? To kind of cancel it out. Now, what this is doing in the context of our problem, as we get 1.40 equals 1.40t. What this is doing in the context of our problem is it's saying, okay, look, I've paid $3.30 for the burger, right? Of that $3.30, $1.90 was for the burger itself, right? So if we subtract that and figure out what the difference is how much extra we paid in toppings. So $3.30 was the cost of the burger. We take out the $1.90 that it was the cost of the burger just plain. And now we have $1.40 remaining. $1.40 is how much we paid for toppings. And since each topping costs $1.40, right, that means we bought simply one topping. T is equal to 1. So we bought one topping. All right. That's more or less what these next few problems go about doing. So I'll kind of hustle through them a little bit. Rewatch the video, rewatch these questions if you need to sort of try and figure it all out. Number 1 is going to be where most of the explanation was, but let's just go through 2, 3, and 4 quickly. So here we have a function about ice cream sundae with toppings again. So remember, this is the same, essentially, if you rearrange it as y equals 0.75t plus 2.25. You don't have to rearrange it, but sometimes that helps identify the slope in the y-intercept. Now, our y-intercept is that 2.25, right? Now, this represents, remember, 0.75 goes with the toppings. So if we bought 0 toppings, we would still pay 225. So 225 is the cost of the sundae, right? With again, without any toppings. Just the cost of sundae with no toppings, just plain. Very similar to the hamburger problem in number 1. The slope, as we see from our slope-intercept form, is 0.75. Now, because this is relevant to the toppings, right, 0.5 times the toppings, we can deduct that this is the price or the cost per topping. So each topping essentially is costing us $1.50, or not $1.50, 75 cents cost per topping. All right. If K paid $6 for a sundae, how many toppings were on K's sundae? So in this case, $6 is our result. We know that we paid $6 in total. And our function was 2.25 plus 0.75 times t. Okay, sometimes my pen writes well, sometimes it doesn't. So just does whatever it wants. All right, so we solve this equation similar to the last one. So in order to figure out what our price is, right, we'll subtract how many toppings we got. Subtract 2.25 first. So again, what this is doing, remember, is we know we paid $6 for the sundae, and we know of that $6, $2.25 was the cost of the plain sundae, right? So if I take that out, right, and find that difference, the difference is how much money I paid in toppings. So I get 3.75 from this. 3.75 equals to 0.75 t. And when I solve that, when I divide by 0.5, I get t equal to 5. So meaning that we have bought 5 toppings. Okay? Same thing with these functions. The y-intercept on this one, just to make it quicker. If you want to pause the screen, I recommend you pause it, try and solve it yourself, and then I'll just give you the answers. Okay? But if you're looking for an explanation, you can go back and watch 1 and 2. The y-intercept on this problem is 5. And it represents, again, the screen. The pen's still a little fuzzy here. The y-intercept is 5, and that is going to be the cost of the fair admission. So I'm just going to tell you instead of writing it because my pen's not going to work well with me. So $5 is the y-intercept, and that's the cost of going to the fair, but not riding any rides. It's just the cost of showing up to the fair, getting into the fair, the admission fee, if you will. The slope is $1.75. It's 1.75. And that slope represents the cost it takes per ride. So you pay $1.75 per ride. And then if Al spent $19 at the fair, how many rides did Al ride? So I'll just set up the equation for you. You'd have $19 equal to 5 plus 1.75 r. And of course, when you solve this equation, you should end up with r equal to 8. All right. And then number 4. Number 4, again, I'll just read this to you. So the y-intercept, so we have Miss Franklin goes to a buffet and brings her grandchildren. The y-intercept here is going to be 6.85. And what that means is that's the cost of the buffet without any grandchildren. Essentially, that's the cost of the buffet Miss Franklin have to pay. Because if she doesn't bring any grandchildren, right, she's going by herself. If she goes by herself, she's paying $6.85 for the buffet. So that must mean the buffet for her costs $6.85. Kind of like the adult price for the buffet. The slope is $2.95, and that's going to be the price per kid. Every child she brings is $2.95. So essentially, that's the kid's buffet price. It's $2.95 per child. Now, if Miss Franklin paid $18.65 for the buffet, how many of your grandchildren did she take? So 18.65 equal to our equation, which was 6.85. Again, my pen's still a little bit funny here. Plus 2.95c. You solve that equation, and I believe it's 5 grandchildren, 4 or 5 grandchildren, 4 grandchildren. Forgot the actual number. I think I'm gonna go with my gut. My gut tells me I think it's 4. But you guys should be able to work it out. I'm pretty sure it's 4. All right, number 5. So the graph here shows the number of newspapers delivered and total pay for the delivery. What does the slope of the graph represent? So if you look at the graph really carefully, you'll notice we can identify the slope from this point here. We have the point at 20 and 5, right? So essentially, we know that 20 newspapers costs $5, okay? Doesn't seem to work very well, but it's all right. 20 newspapers cost $5. It's just still laggy, and I just can't understand why. All right, so if you simplify that, 20 newspapers cost $5, right? If you actually divide that $5 by 20, you end up with 0.25, right? Or essentially a quarter per newspaper. Now, our slope is relevant to that. Well, that's not the question. First off, the question is not what is a slope; it's what does a slope represent. Our slope, remember, is about change in y relative to a change in x. And if we look at this is the change in y is money, right? Change in x is newspapers delivered. So essentially, it's going to be our price relative to our newspapers. So essentially, as we mentioned here, our slope is cost per newspaper. Okay, the slope represents the cost or the price per newspaper. Number 6. I don't know how you say that name. Dion or maybe Diane, I know, really weird spelling, pays a fixed fee plus an hourly rate to rent a boat. The table below shows the price she paid for the boat. What's the hourly rate? A common mistake here is to think that the hourly rate is $27 because it says 1 hour is $27. But that's not the hourly rate. Okay, the hourly rate is actually $12. Okay, and we can figure that out because of the difference in hours, right? From 1 hour to 2 hour, from 2 to 3, from 3 to 4, from 4 to 5. Every hour is increasing by 12, showing us that the hourly rate is $12. But why is it not 27? Let's quickly explain why it's not 27. How come the first hour is 27? And that's because in the first hour, she's paying a $12 for that 1 hour rental, but she's also paying, as it says in the problem, she's paying a fixed fee plus the hourly rate. So in the beginning, she has to pay a fixed fee. So that first hour includes the $12 for the hour, but it also includes the fee. Now, if you take the difference, the difference between 27 and 12, you take 12 out of 27, that fee must have cost $15, right? The question doesn't ask us for that information, but I'm explaining why that 27 is there. Essentially, what Diane's doing here, or Dion, is she's paying $15 as the fee and then $12 for the first hour. Meaning for 1 hour, she pays that $27. But she doesn't have to pay that fee anymore. So every other hour, she just adds an additional $12 to her total. Okay, that's why in the first part, we see 27, because she has to pay not only the $12 fee, but she also has to pay the fixed fee up front. All right, and then our last problem. Is this the last? No, it's not the last one. Colby paid $100, put $100 in savings. What is the y-intercept? What does it represent? So the y-intercept is here at 100. So the y-intercept is $100. Now, what does this represent? Well, it represents the amount of money Colby started his savings account with, right? That's at the beginning of the savings account. He starts with $100, and that's what it says in the beginning. But that's what our y represents. Our y-intercept is that 100 because Colby is starting his savings account with $100. So it's the amount of it that he puts in the savings account at the beginning. All right, Charlie rented a moving truck. He paid a daily fee plus a per mile fee to rent the truck. So here we have that slope-intercept equation again. So we can see that the slope from this is 0.5. We know that from our mx plus b stuff. So 0.5 is our slope. But what does that slope represent? So think about it, right? Y, you have to know what the x and y represent. So y is representing the cost. X is representing miles, right? So it's 0.5 for the miles. If you go 0 miles, you would pay $10 because you wouldn't pay anything for that 0.5. 0.5 times 0 would be nothing, right? So you just end up, if you went 0 miles, you just pay this $10 because you went 0 miles. But if you go a certain number of miles, you're paying 0.5 for each of those miles. So essentially what our slope is representing is it's the cost, it's that per mile fee. It's the cost per mile. 10, if you're wondering, 10 is sort of that upfront fee. The fee to rent the truck, but not the fee for the miles driven on the truck, just the fee to rent it. That was 10. The fee for the miles was the 0.5. Write a linear equation in slope-intercept form to model each situation. So slope-intercept form is, of course, y equals mx plus b. Okay, my pen seems to be working well there. Let's hope it stays that way. Right? If we rent a bicycle for $20 plus $2 per hour, $2 per hour is our slope, right? So this would be y equals 2x, because it's 2 per hour, plus the $20 fee. So there's our equation. We're just essentially putting these numbers in for the m and the b. The 2 is our m, and the 20 is our b. An auto repair shop charges $50 plus $25 per hour. So it's very similar. This is going to be $25 per hour is our slope, so 25x, plus the $50 fee. Number 14, a candle is 6 inches tall and burns at a rate of a ½ inch per hour. Now this one's a little different because you're burning the candle means the candle's not actually getting bigger. The candle's getting smaller, right? The candle's losing ½ an inch in its height per hour. So the way we write this, there's actually 2 ways you can do it. The intuitive way is saying, hey, we start with 6 inches, right? The candle does, and then you're subtracting ½ an inch every hour. So 1/2 x for 1/2 every hour. So you can write it like that, but if you want to put it in mx plus b form, just rearrange it. You can also write it as negative 1/2 x plus 6. That works as well. And then number 15, the temperature. Temperature is 15 degrees and is expected to fall 2 degrees each hour during the night. So again, we're decreasing. So if you write it like number 14, sort of use your instinct, right? You would say, hey, we're at 15, but then we subtract 2 every hour. So minus 2x. 15 degrees now, and then subtract 2 every hour. So subtract 2x. Again, you can also write it the other way around, negative 2x plus 15. That would work as well. All right, that's it for these notes. It's really not too much. There are some simple things you can make mistakes on, but overall, I think we get it for the most part. Let me know if you have questions in class. I'll see you guys later.